We are just finishing up our loop section, which Burke taught you all about with the for and while loop, two different types. Remember, a for loop is what you use if you know how many times you need to repeat a set of commands, and a while loop is used when you know the condition in which you need to repeat a set of commands, but you don't know how many times. So what we're going to be starting today is on functions, and so this is, just so you know, oops, that was unplugging it. This is the topic that the quiz is the most difficult because it changes the format of the quizzes significantly. So what I mean by that is from here on out, all of your quizzes will be written as functions. So we're no longer going to be writing script files, we're going to be writing function files. So it just changes the game quite a bit, this topic. So it's really, really important that you think carefully about functions and what this means, because they're going to be in every single thing that we do from here on out. Okay, remember how this happened last time where it didn't work over here? You're like, no, what are you talking about? Just making noise. It's weird. Okay. So let's just talk a little bit about what functions are, and then I'm going to give you a bunch of examples in MATLAB. So the biggest difference starts just when you open the file. So far, every time we've started writing a script file, we've opened up something called a new script. And script files behave a little bit differently than the function files we're going to be writing. So that's what we're going to try to understand today. And the idea behind the script files that we've been writing is they're basically just convenient. Instead of executing lines of code individually in the command window one at a time, it allows us to put all of our lines of code together in a file so that they can run all together. And that's all a script file really is, right? It's just a convenience. Where a function, which we're going to start today, allows us to have inputs and outputs into our script file, basically. So I think I'm going to actually show you how you start them in MATLAB, and then I'll come back so you can actually kind of envision it as we're talking about it. But the only difference is that a MATLAB function file is a script file that allows for inputs and outputs. So let me just show you, before I start explaining the format of a function file, let me just show you in MATLAB how you get one. So we've always just been clicking like Control N or opening up a script file, and it's just this blank text file, right? If you go down to the function option and open it up, what you'll notice is that it gives you a wrapper that has a function and an end, just like what you're used to with for and if and while. Right here is the file name or the function name, and then it allows for inputs and outputs. And so there's this nice wrapper that's created automatically when you open up an empty function file, but you can also just create these on your own. So this is what we're going to start looking at, is this. So let's talk about what that means. So the first thing you have to understand about a function is the function declaration line. And that is that line that just came up when I opened up the file. It's the wrapper that is created that has the word function, and in a couple lines below it has the word end. And anything in between function and end is contained within the function. The syntax for a function is that you put any outputs that you would like to retrieve when running your function file, you put them in square brackets in front of the function name. And there's an equal sign in between the function name and the square brackets. And then the function name goes immediately after the equal sign. And what's important and what you want to get in the habit of doing is if it's the first function in your script file, you want to name the file the same thing as the function. That's the best practice you can use. Yeah?
So you're giving MATLAB the outputs you want?
It'll make more sense when we write some, but this is a way to run a script file that takes stuff in and sends stuff out. Right now your script files are just run. Everything is just set inside the code, but let's say that the code that you're running right now sets the grid to 100 by 100. Let's say that you wanted to be able to vary that and sometimes have it be 1,000, sometimes have it be 10 by 10. You could put that dimension as an input to the script file, and that way all you'd have to do is when you run the file indicate the dimension in parentheses behind it. So I'll give you lots of examples, but the inputs are in parentheses separated by commas behind the function name. You don't need any spaces in any of these spots. So you'll notice that even when you open up the function the function script file, it'll provide this for you because it's very important that your function has a comment at the start that describes what the inputs and outputs are expected and what the purpose of the function is. And then the rest of the function is your list of commands. So typically we write script files as function files when the script has something that's changing that we would like to easily change and get output from. So again, there's a couple important things about this. And this is in your pre-lab, but when you have outputs for functions, this is confusing to most people. They need to be in square brackets, but here are your options. You can have 0 outputs, 1 output, or as many outputs as you would like. Same with inputs. They're in parentheses, but you can have 0 inputs, you can have 1 input, or you could have as many inputs as you want. So you could write a function that has no inputs and outputs. That would actually be allowed. And I'll explain to you why you would ever do that. I actually only write functions. I never write script files. And so all of my functions have no inputs and outputs, but I write them that way for a reason. So there's 2 ways to write a function file. So I showed you the first way, which is to use the wrapper that's formed when you create a new function. But there's actually nothing special about this file. It's still an M file. It's still going to have the .m extension. And so you can actually just write your own function. There's nothing different about the one that's created automatically. It's just code. So I can write the same thing on my own and save it. And this is still a function file. So either way works. You can convert any of your script files into function files. So let's talk a little bit about what a function is now that you've seen the syntax of it. So the thing is that you guys have been using functions already. You use them in every code that you've written. We just haven't talked about what they mean yet. So let's say that you want to find the minimum of this array V. To do that, you call the function that has the function name min, M-I-N, and you give it the input V. the output of the function min, if you only give it one input, is what? What's the output of this going to be? It's just going to be 2. So I didn't provided an output to go to or anything. I just ran the function, and it's just going to give me its first output, which is the value of the minimum. So that's an example of calling a function that already exists in MATLAB with one input. But as you guys know, you can also call the min function, and you can save the output to a variable, which is what we normally do. So in that case, the min function gets called, the minimum value gets calculated, and then the minimum value gets saved to the variable that you indicate, which is mn in this case. So this is an example of calling a function with one input and saving it to one output. The min function allows you to have multiple outputs though. We've used it before. So another option is you can provide 2 outputs to the min function. So when you call the min function, what does the second output save? It saves the location of the minimum. So in this case, you're going to get the min equal to 2 and then the location equal to 1. So this is just a function file. We could write our own min function, and we're going to today. But all MATLAB is doing is providing the function rules, which is that you can indicate in the writing of a function as many inputs and as many outputs as you want. And then there's rules for outputs. You can run functions and not provide any outputs for it to go to, and it will just give you the first one. You can give it one output to go to, and it will save it to that variable. Or if you provide it 2 outputs to go to, it will give you both outputs. Questions? Yeah.
What is IND?
These are just variables that I've chosen for my outputs to go to. Outputs can be, you can use any output you want. So I'm just giving you this example because we've used the min function quite a bit.
Right, so but IND hasn't been defined.
I'm defining it in this call. So this is 2 variable definitions. Min and IND are both getting defined in this call. Do you have a question?
Yeah, can you switch it to the overhead can not be recorded?
Oh, sure. Was that it?
Yeah.
Oh, okay. Okay, and then any other questions about that? So that's one function that we've used quite a bit. There's max that you've used quite a bit, and find is a function. Any of these that we've used are all functions that follow the functioning rules. So let me give you an example of a function that we've used that we've provided 2 inputs to. So the input function is another function. It's a little confusing because there's inputs to functions and then this function name is input. But remember that this function is used to prompt the user for a response, and so you give it a string and that string goes to the screen. But if you remember from several instances, we provided a second input, which was the S string, which indicated that the output was going to be a string. So this is an example of a function call with 2 inputs and 1 output that we've already used. So the idea here is that there's all these intrinsic functions in MATLAB that we use all the time. And now, in this topic, we're going to spend a little time understanding those, like what we just did of what we're actually doing there, providing inputs and outputs to those functions. But what we're going to spend most of our time on is writing our own user-defined functions. So it used to be in MATLAB that you could actually open up any M file and read the function. So like if we wanted to see how the min function was written, you would just search your computer for min.m and you could bring up the M file and you could just look at the code that they wrote in order to find the minimum. They've now taken all of that away. You can't look at it all. It's all blocked somewhere. But it does exist somewhere. It's just an M file. And so what we're going to do today is write our own min function and a couple other functions to see how those work. Do you have a question?
My question was if you just did the array with
number, if you just did that, what would the error be?
Here?
Yeah. And didn't set equal to the min of e. Like, what would the error that it would give you?
Say it again. I'm
I guess, why do you have to have that, like, the function and the input on the right-hand side? Why do you have to have it equal to something?
You don't. That's the first example. You can just write the function without anything, but then it will only provide you with the first output, and it won't be saved.
So can you write that output instead of the input? Does that make sense? Like, because you wrote, like, hard bracket mn comma index. If you just wrote that, what would it give you?
It would give you an error because it would look for variables that were called mn or int. Remember that MATLAB always reads from the equal sign to the right. So what MATLAB does is it says, oh, you want to find the min of something. I'll go grab that function. I'm going to input this array into that function and calculate whatever that function calculates, and then I'm going to save those results to these two variables. If you just put those variables in, it would go look for those variables which would not be defined yet. Any other questions? Okay, so I'm going to give you, we're going to write a couple user-defined functions. So we're going to start with a simple function that has one input and one output. And all the function is going to do is define a quadratic equation. So I'm going to write a function that defines x squared plus x minus 2. So let's do that. So let's start from scratch. Let's start from a blank script and create our wrapper. I'm going to save this function name as defineF. And as I said, there's going to be one input and one output. So you always want to start with saving those in the function declaration line. You can use any variables you like here. For convenience, I could just use variables that relate to the application. So I could use f and x, for example. Now, this code is going to be very simple because it's one line of code inside the function. So the code is just going to take the input x, it's going to square it, add itself, and then subtract 2 based off of the function that I just wrote down. And then it's going to save that calculation to the output variable f. Ooh, I didn't mean to use define. I meant to use defineF. That's okay. So this function I wrote is saved to my desktop. So this is what every one of you, not every one of you, 75% of you are going to do this. And Quentin, do you guys have, any of you have Quentin? Last year, I said the same thing in lecture, made a big deal about it. He brought me over and he's like, it's not working. And I'm like, do you remember what I said in lab? Actually, I didn't even say that. He just said, oh yeah, you said something in lecture about how we were supposed to blah, blah, blah. So listen, just plant this in your brain. If you write a function file and you click run, it's not going to work, ever. Because function files that have inputs require inputs to run. Because what happens is it says, okay, I'm going to run define. It goes into the code, and it just starts going right at the equal sign, x squared. And it freaks out because it doesn't know what x is because you didn't tell it what x is, and so then it gives you the error. So the only way to run function files is to provide all the inputs that are defined. So that's the biggest change. To run the file, it needs inputs. So if I provide 2 as my x value, when I run define, it's going to calculate the f and output it to the f output variable. And just like when I just showed you how to use the min function or the input function or the max function, you can save this output to a variable so then you can use that later. Or you can just run the function without outputs and it will just print it to the screen and not save it. But remember, if you have more than one output, the only way to get the second output is to call it in the function call. So for example, if I want to add a second output, to this function, so I'll just take the f value and multiply it by 2, and then I add a second output to this call. Again, there is no problem with not providing outputs for it to go to. It'll just give you the first one. If I provide it one output variable, it'll give me the first output variable. And then if I provide it two output variables, it'll give me the second one. And that's just the same way that the min function works that I just showed you. You don't have to provide that second function call, but if you do, it will give you the second output, calculated output. So that's the first trick. I want to see if anyone can figure out what the other big difference between a function and a script is. So I'm going to run my function. I'm just going to do it without any outputs. I want you to pay attention here to the workspace. So I call it, what's different about the workspace in the function versus the script? Yeah, none of the variables in your function come to your workspace. And that's what we call a black box function, and that's in the pre-lab 2. The idea is that when you use the function, you only know about the inputs and outputs. You don't ever get to see what's going on inside the function, outside of the function, if that makes sense. So that's why we use functions, is because it makes it so that you don't mix up your variables, because your variables are contained within the function. So if you want to reuse variables instead of coming up with 1,000 different variable names, you can just use the function and it will not get mixed up. So those are the two big things. Write this down. When you call a function, you need to provide the inputs or it's not going to run. And the second thing is your workspace is not going to be aware of anything that's going on inside of your function. So when you start working on the quizzes, for example, that's a big change because I think a lot of you are used to looking at your workspace to checking things and to seeing if things are right. So now you're going to have to get in the habit of either converting back and forth between functions while you're debugging or start printing stuff as you're running the function. So stop suppressing stuff so you can at least see it. You know, when you're running it, you can see some of the intermediate calls that you're trying to figure out. Question? No. Okay. Yeah.
So you just show F2. It showed F2. Wouldn't that be a variable from the...
Yeah, because I just unsuppressed it. So that's if you want to be able to see things that are going on in your code, you're going to need to start suppressing things, unsuppressing things, or doing something else for your debugging that you might not be used to. So that's something that you're just going to have to practice a little bit. Okay, so here is the next thing that I wanted to show you. So I'm going to create just a regular script file. This could be a function file too. But the idea behind functions is that you can call them in other M files and script files. So for example, let's say that I wanted to calculate the f value for 20 different x values. So I'm just going to write a loop that runs through all the values of x, and I'm going to fill in an array f with the values that come out of the function that I just wrote. So define here is the function that we just wrote in this file here. And I've just saved them both. They're in the same folder here. Test is this file, and define is this file. And let's just plot the result. If I run test, what it did is it plugged in 20 different x values into the define function that we just wrote and saved each of those x values to a different element of the f array that I created, and I just plotted it. And it's a quadratic function, so this makes sense. It's a quadratic plot, right? And so this is really where the benefit of using functions comes in. It's because once you start repeating things over and over, you just put everything in a function and then you call that function rather than copy and pasting your code. So that's how you call a function from within another script file. But what you're going to be doing most of the time in this class is you're going to be putting all your functions in the same file. They don't need to be that way, but for our purposes, it's convenient because then when you submit files, you just submit one file to us for quizzes or for assignments. So,
Question.
yeah,
So you said that we can have more than one function in one file. So
yes.
if we have more than one function, what function would it pull out since we have more than one function?
It always just runs the first function. If any of the bottom functions aren't called, they don't get run. So here what I've done is I've taken that test script file and I've converted it to a function. So I put all that code that I originally had in here, I put it all in its own function called test, and I have the wrapper function and end wrapped around that code. Then, not nested, just set underneath it, I've put in the define function. So the way that this works is if you have a user-defined function define that's called within another function, it will first search the file. If there's any function inside that file with that name, it will use that. If there's not, it will search the folder, and then if there's nothing, then it will cause, there'll be an error. So it's going to search the file first. So this is going to work exactly the same, and then I can even delete this define function that I already wrote. I'll just delete it, and so now the function only exists in, if you see here, it's only existing in this file. So now it's just going to produce it from the file itself. So this is how most of your files are going to be set up, with a main function, and that main function will have the same name as file name, and then any sub-function will be set underneath it.
And so is this basically how most computer programs work? Because if you go into the computer program, say Adobe Illustrator or something, there's like a bunch of files that are like a bunch of files in the existing file location, and those all interact with each other?
Yeah, typically, yeah. A lot of those things you can't really see much of it because they don't want people to be able to get into the software coding, but yeah, it's very typical how software works in general.
So you have the function and you have it, and you told it what to do, but then it doesn't know what f is. Wouldn't it run from 1 to 12, and then it wouldn't know what f is?
It doesn't know what f is where.
At the bottom, so like if it runs from the beginning, from function test, and then it would go like an I, and then I equals define. Does it know what f is?
This is a variable definition. So remember, anything, it calls anything on the right-hand side of the equal sign, and then it places it in the variable on the left. So I'm defining this variable, so it doesn't need to know what it is. So this variable is getting filled, and you'll notice that I've repeated and used the same variable name here and here. The only reason it's not getting confused with that is because functions are black boxes, and so anything that goes in and out of this function does not get mixed up with anything outside of that function. But a lot of programmers don't write code that way because they themselves get confused about their code, and so a lot of programmers will get into a habit of using unique names for all their variables, but they're not necessary, and it's just sometimes hard to keep track of all the variables when you do that. So I wanted to show you a min function. In your code that you're going to be writing for this lab, you're going to be writing a max function. So I just want to show you how you can write your own min function, for example. So I'm going to just write it in this file and call it in this file just because it's easier to do. So this is exactly how the intrinsic min function works. So like when I call the min function and I give it a couple different values in an array, the function is just doing this algorithm. So I have my function set up where it's going to take the minimum value of the V array. So this is in your pre-lab, so you can go back and look at this algorithm and really understand it so that you can translate it to your max function, but I just wanted to show you it here on the computer. So the way a min algorithm works is that you are trying to locate the minimum value inside the array. So you're basically going to just create the same function that we've already, or the same algorithm that we've already wrote, which is you're going to search through an array to find a condition. So for example, we've already done this with so many of the codes. You just search through every element of the array that you're looking at, and then you have a condition that you're looking for inside that array. So in this case, we're looking to find that the value of the array element is less than some minimum value that we're trying to determine. So for example, you can set the minimum value equal to something really big that you know there will be something smaller than that in the array, or you can just set it equal to the first element of the array. It's up to you. So what this will do is it will check the array. So let's say the array is the array that I just put in here, 5, 6, and 3. So mn is going to start out with a value of 5. It's going to run through and check the first element of v, which is 5, and check if that's less than 5. It's not, so it's going to skip it. Then it's going to go and check for I equals 2 if 6 is less than 5. It's not, so it's going to skip it. And then it's going to check if the third element is less than 5, 3, which it is. So what do we want to do if it finds a value that's less than min? You want to replace it, right, with that value. So the algorithm for a min is pretty straightforward. You just replace the value with the value that you just decided was smaller than it, or that the computer just decided. So that's a min algorithm. You can think about that a little bit more and how you would convert that to a max algorithm. But then if you wanted to call my min, let's say we wanted to find the, I'm going to create a different one because I'm going to call my min. I'm just going to not suppress it here. And what did I do? Oh, I changed the f value. So here is the output. The only thing that I suppressed in this code is, or unsuppressed in this code, is my call to my min. So it found 3. So that's good. Let's see if we can put something else that's not the last element. So here 0 is the min, and it found the min. One thing to keep in mind is that if you have a function written inside of another file, like my min, I'm not going to be able to call it from this main function. So it doesn't know about it because it's not saved as its own file. So if I try to call my min, it's not going to know what that is. So you have to save your functions as either their own files to use them outside of the file, or if you're just using them inside the file, they can be within it. The last thing that I wanted to show you is that if you write your own function, so right now I have, oh, you already know that because it's the same with the script file. The autocomplete works for functions too. So if you start writing the function, you can use the tab to autocomplete. Yeah?
Under my min, how did it know to call the 0 instead of the 3? Because both of them were less than 3.
So with that example, where is it? So v is this. I'm just copying it in here so you can see it. So it's always going to update it. So first it's going to check 5. 5 is never going to be less than itself, so it's going to go on to 6. 6 isn't less than 5, so it skips it. Now 3 is less than 5. So now mn is going to equal 3. So the mn value is changing. Then when it checks 1, it's going to check 1 compared to 3. Since 1 is less than 3, it's going to go into the if statement. It's going to now update mn with 1. It's going to keep doing that. So it skips it if it's not less, and then if it is, it replaces it. Any other questions? Yeah.
I know that in Java and C you can make multiple functions with the same name but different inputs to do different things.
I don't think you can do that.
Not in MATLAB?
I wonder what it would do, if it would give you an error or if it would just use the first function call. But you definitely, I actually don't know.
So for functions like input where it has a second thing that you can
Optional
put in
ones?
or not, how do you set that up?
I don't know. That's a good point. Maybe it does let you write multiple function declaration lines. Any other questions? Okay, thank you.